In section 5, we're going to talk about trig equations and more specifically how to solve a trig equation. Now, unlike trig identities that are true for all angles, so for any value of x, sine squared x plus cosine squared equals 1, trig equations are only true for some angles. So there's only some angles where sine of x equals 1. So there is a difference between an identity and an equation. So when we solve trig equations, we find the values of x that make the statement true. So for that sine of x equals 1, that's true when x is pi over 2, 5 pi over 2, 9 pi over 2. So we generalize the solution to be x equals pi over 2 plus 2 pi k. That way I can account for all of the coterminal angles with the solution. So in this first example, we want to solve 2 sine of x minus 1 equals 0. So on our steps here, we have it equal to 0. The first step here would be to add 1, and then we divide by 2. And then we would take the sine inverse. So our solutions are everywhere on the unit circle where sine is 1/2. So we are going to be using our unit circle. So sine is 1/2 at 30 degrees and 150 degrees. So we write an expression that lists all of the solutions for our coterminal angles. So that's where the plus 360k comes from. It includes all coterminal angles with 30 degrees and 150 degrees. So similarly, we can solve the equation sine of x plus radical 2 equals negative sine of x. So by collecting the sine x terms on one side, what we did was we added sine of x. Then we subtracted radical 2, and then we divided by 2. So our solutions for x are sine inverse negative radical 2 over 2. So everywhere on the unit circle where sine is a negative radical 2 over 2. So it happens at 5 pi over 4 and 7 pi over 4, and then we add the 2 pi k for all coterminal angles. Let's go ahead and do an example. So in this example, we want to solve 2 cosine of x minus radical 3 equals 0, and we're only solving on the interval 0 to 2 pi. So we're not going to account for coterminal angles in this example. So the first thing we're going to do is to add the radical 3. So we get 2 cosine of x equals radical 3. Then we're going to divide by 2. So we have cosine of x equals radical 3 over 2. So our solutions are going to be when x equals the cosine inverse of radical 3 over 2. So on the unit circle, we're looking for when cosine is radical 3 over 2. And that happens when x is pi over 6 or 11 pi over 6. And again, because we're only looking on the interval 0 to 2 pi, we don't need to have that plus 2 pi k. If you wanted to list the answer in terms of degrees, pi over 6 is 30 degrees and 11 pi over 6 is 330 degrees. So we could also list our solution in degrees. So some equations have additional steps. So if I'm solving 2 cosine of 3x minus 1 equals 0, so that involves a multiple angle, we don't actually divide by the coefficient of the angle, we actually isolate the cosine 3x term, just like if it were a regular cosine. So the first step we did was add 1, then we divided by 2, and then we actually got that 3x equals cosine inverse of 1/2. So the first thing you're going to do is find all of the values on the unit circle where cosine is 1/2. So that's where the 60 plus 360k and the 300 plus 360k come from. Then you divided by 3 to find when the solutions for x. So then we divided by 3. And we get that x equals 20 plus 120k or 100 plus 120k. So you first isolate the 3x using the unit circle, then you divide. So let's apply this to an example. So we want to know when 2 sine of 2x equals -1. So our first step is going to be to divide by 2. So we have sine of 2x equals -1/2. So this tells us that 2x equals sine inverse of -1/2. So our first part of our solution is to find the angles on the unit circle where sine is a -1/2. So that would be 210 degrees plus 360K, and then 330 degrees plus 360K. So notice in this example, we didn't specify that we're on the interval 0 to 2 pi, so we do have to account for all of our coterminal angles. So this is the solution for 2x. So to get the solution for x, we now divide everything by 2. So our solution is x equals 105 degrees plus 180K and 165 degrees plus 180K. So those are the solutions to our equation. In other cases, our trig equation is in the form of a quadratic, so we can either use factoring or the quadratic formula in order to solve it. So for our first example, we want to find when 2 sine squared of x minus sine of x minus 1 equals 0. So when they factored the equation, you can kind of think of y equaling sine of x. So you can rewrite that quadratic as 2y squared minus y minus 1. And then that quadratic factors as 2y plus 1 times y minus 1. And then you rewrite it with sine of x being plugged back in. So that's how you get the sine of x minus 1 times the 2 sine of x plus 1. Then just like a regular quadratic, you take each factor and set it equal to 0. So we have sine of x equals 1 after isolating it, and 2 sine of x equals -1. So our first solution is all of the values where sine inverse is 1. So when sine is 1, which happens at 90 degrees, and then plus the 360K. After finishing isolating sine, our second solution is when we have sine inverse of -1/2. So when sine is a -1/2, which is 210 degrees plus 360K and 330 degrees plus 360K. So we actually have 3 solutions in all of their coterminal angles. We can also use factoring in an example like cotangent times cosine squared equals 2 cotangent of x. So what they did first was they subtracted the 2 cotangent of x, then they factored out a cotangent of x since both terms now had a cotangent of x. So then we want to find when cotangent of x equals 0 and when cosine squared x minus 2 equals 0. So that's how you get the first solution. So we're looking for whenever cotangent is 0, which happens at 90 degrees plus 180K, because remember cotangent only has a period of pi, so when I'm doing my coterminal angles, I go by 180 degrees. Now our second solution here, the cosine squared of x equals 2, when we take the square root, we get that cosine of x can equal plus or minus radical 2. Well, cosine of x can't equal radical 2, because the range, remember the range for cosine is from -1 to 1. Radical 2 falls outside of that range, so there is no possible solution from the cosine squared x minus 2. So our only solution is the 90 degrees plus 180K. So let's do a couple of examples of these types of equations. So we have sine squared of x minus 3 equals 2 sine of x. So our first step is going to be to subtract the 2 sine of x. So we end up with sine squared of x minus 2 sine of x minus 3 equals 0. So if I want to, now I have a square term, so I want to factor it. So I'm going to let y equal sine of x. So I have the quadratic y squared minus 2y minus 3. Well, if I were factoring that quadratic, I would factor it as y minus 3, y plus 1. So now I can rewrite this as sine of x minus 3 times sine of x plus 1 equals 0. Now we take each factor and set it equal to 0. So we have sine of x minus 3 equals 0 and sine of x plus 1 equals 0. Solving our first equation, we add 3. We get sine of x equals 3. But sine of x cannot equal 3 because remember, the range is only between -1 and 1. So I don't actually get a solution from that factor. My second factor, when I solve that equation, we subtract 1. We get sine of x equals -1. So we're looking for our solutions are when x equals the sine inverse of -1. So using our unit circle, the only time sine is -1 is at 3 pi over 2. So our solution is when x equals 3 pi over 2 plus 2 pi k. You could also again write the solution in terms of degrees. So you can get x equals 270 degrees plus 360k. These are equivalent answers. Last example, -6 times sine squared x plus cosine x plus 5 equals 0. So when we're solving a trig equation, we typically only want one trig function, unless we're going to be able to factor something out, like in one of our examples, and have two separate equations. But that can't happen here. So what I'm actually going to use is I'm going to use a Pythagorean identity. We know sine squared of x equals 1 minus cosine squared of x. So I'm going to use this identity to get an equation that only has cosine. So replacing my sine squared with that, we have -6 times 1 minus cosine squared of x plus cosine of x plus 5 equals 0. Distributing the -6, we get -6 plus 6 cosine squared x plus cosine x plus 5 equals 0. So we end up with the equation 6 cosine squared of x plus cosine x minus 1 equals 0. So now we have a quadratic equation involving cosine. So if I want to factor it, we let y equal cosine of x so we have 6y squared plus y minus 1. Well, when we factor this quadratic, it factors as 3y minus 1 times 3y plus 1. Sorry, 2y minus 1 plus 1. 3y minus 1 times 2y plus 1. So rewriting my equation, we have 3 cosine of x minus 1 times 2 cosine of x plus 1 equals 0. Taking each factor as a separate equation, 3 cosine of x minus 1 equals 0, and 2 cosine of x plus 1 equals 0. Solving the first equation, we add 1. We get 3 cosine of x equals 1. Then we divide by 3. So we have cosine of x equals 1/3. So our solutions are going to be when x equals the cosine inverse of 1/3. Now 1/3 is not a ratio given to us on our unit circle, but cosine of x can equal 1/3. It is within the range. So our solutions are actually going to be 1.23 plus 2 pi k and negative 1.23 plus 2 pi k. That's one of our solutions. And to get the 1.23, I just used the calculator to find cosine inverse of 1/3. So our second equation, we're going to subtract 1. We get 2 cosine of x equals negative 1. Divide by 2. We have cosine of x equals negative 1/2. So our solutions are going to be when x equals cosine inverse of negative 1/2. Now cosine does equal negative 1/2 on the unit circle, so we can use the unit circle to find our solutions. X equals 2 pi over 3 plus 2 pi k is one solution. And then our second solution occurs at 4 pi over 3 plus 2 pi k. So in this case, both of our factors gave us solutions. So we actually have 4 solutions and all of their coterminal angles.